Good day students. So as part of our organic chemistry 3CH416, in today's lecture we will look at the reactivity of carbonyl compounds. Carbonyl compounds are very interesting organic chemicals and are clinically highly relevant, and they undergo a very interesting reactions which are called as nucleophilic acyl substitution reaction. So nucleophilic acyl substitution reaction. So what does this mean? So let's take a organic molecule or a carbonyl. Let's represent a carbonyl compound like this, and let's say a nucleophile is represented by say Z, and as an outcome of this nucleophilic substitution reaction you will get something like this, where this substituent has been replaced by the nucleophile. So nucleophile, which is Z in this case. So this is a typical example of a nucleophilic acyl substitution reaction. Now this reaction is possible because carbonyl compounds can add to this nucleophile and form what is referred to as a tetrahedral intermediate. So upon addition of this nucleophile, a tetrahedral intermediate is formed, and this is made possible because of the ability of the oxygen to bear a negative charge. And the next, so this is the first step of the reaction. So this is the first step of the reaction, and in the next step this tetrahedral intermediate breaks down, and the leaving group, which is X here, gets eliminated, giving rise to a new carbonyl compound where the X has been replaced by Z. So this is a typical nucleophilic acyl substitution reaction, and this is made possible because of a tetrahedral intermediate that is formed because of the ability of this oxygen or the carbonyl oxygen to bear the negative charge. So from the above one can conclude that the ability of the nucleophilic acyl substitution reaction, the ability is determined by the ability of the carbonyl compound to undergo the nucleophilic acyl substitution reaction is determined by the ability of this X to leave. So this is the leaving group, and so greater the ability of it to leave, greater the ability of the X or the leaving group to leave, faster or easy is the reaction. So we have seen that in our previous class, carbonyl compounds can be classified into aldehyde, ketone, acids or derivatives of acids. Now we will look at which derivative or which carbonyl compound react faster and which carbonyl compounds are least reactive with respect to nucleophilic acyl substitution reaction. Now let us recollect our SN1 or rather SN2 reaction. So there we said that when an alkyl halide, let's say something like when an alkyl halide is attacked by a nucleophile OH minus, you get something like, so this is a typical nucleophilic substitution reaction which we have seen when we were discussing about SN2. Now there we said that alcohols, okay, so alcohols do not undergo nucleophilic substitution reaction. We said that alcohols do not undergo nucleophilic substitution reaction because of the simple reason that OH minus is a poor leaving group, whereas here the reaction occurs because X, which can be a chlorine or a bromine, is a good leaving group. So similarly, for in case of nucleophilic acyl substitution reaction also, we can say whether the reaction happens quickly or faster depending on the ability of the leaving group. So let's look at the relative reactivities of carboxylic acid derivatives. So this is the relative reactivity of the carboxylic acid derivatives. Here you will see that the acyl chloride or acid chloride is the most reactive of the carboxylic acid derivative when it comes to nucleophilic acyl substitution reaction, and amide and acids are the least reactive. So acid and amides are the least reactive when it comes to nucleophilic acyl substitution. Now let's write just below this, let's write what is the leaving group in each of this carboxylic acid derivative when they undergo nucleophilic acyl substitution. So in this case it is Cl minus. In this case it is, let's say for example, it is CH. In this case it is OR. So you have minus here, and in this case it is OR minus, and in this case it is OH minus, and in this here in case of amides it is NH2 minus. We know that these are strong bases, and hence are poor leaving group, and hence they are poor leaving group. Why? Because they are strong bases, and we have seen that strong bases are poor leaving group, and hence these are least reactive. So if you look at the relative basicities of the leaving group, we see that the chloride, which is a weak base, so chloride is a weak base, and hence it is a good leaving group, whereas OH minus and NH2 minus are strong bases, and hence they are poor leaving group. So that explains why acid chlorides, anhydrides are excellent reagents or molecules or functional derivatives of carboxylic acids. That is, so we can conclude that acid chlorides are acyl chlorides, anhydrides are excellent reactants for nucleophilic acyl substitution reaction, and acids and amides are poor reactants for nucleophilic acyl substitution reaction.